We are going to write a simple Java program to find average of three numbers. The first line here is a comment. This double slash denotes a single line comment. Comments are used to write information about the program. Next line is we have defined a class. Syntax for class definition is class keyword followed with a class name. Our class name is average. It can be any logical name you want to write. All the code should be written inside the class. Define the main method. The signature for main method is public static void main and it takes string array as a parameter. Write the code inside the main method. Next thing we do is define the variables. We are finding average of three numbers, hence we need three variables for storing the numbers and one more variable for storing the calculated result. If you want to store numbers with decimal points, Java has given us two data types, float and double. Float takes 4 bytes of memory and double takes 8 bytes of memory. Depending upon your requirement, you should select the data type. Now the points to remember are, if you are using float data type, for example float a equal to 86.34f. Your float keyword tells the compiler that data type of variable a is float. Float is a keyword that denotes float data type. A is the variable name. And while assigning value, for example 86.34f, you need to append f to the end of the value. If you are using double data type, for example double, b is the variable name and 56.34 is the value, you can just directly write the value in decimal point. Now here, if f is not appended to the value, compiler gives an error. So why is that compiler gives an error if you don't append f to the value? See, Java is a strongly typecast language. What do you mean by typecast? Typecasting is when you assign value of one data type to another data type. For example, int I equal to 22.8. If you try to store a number with decimal point in an integer value, this will become a lossy conversion because int data type only stores value 22. 0.82 will not be stored. Hence, Java compiler does not allow to store such values. Now, there may be times where you get an answer in decimal point and you want to store only integer value. In that case, you may do explicit typecasting. We will have a separate video on how to do implicit and explicit typecasting. Now, to store a decimal point, Java has given two data types, that is double and float. Float takes 4 bytes of memory. Double takes 8 bytes of memory. Double data type is bigger than float data type. Now at compile time, compiler has to check whether the programmer has assigned correct value as per the declared data type. Float and double both takes values with decimal point. So how will the compiler come to know which is float value and which is double value? To distinguish this, the programmer appends f to the value to make the compiler understand that it is a float value. If f is not appended, compiler thinks it is a double value. That is why you get an error because by default compiler takes it as a double value. And you cannot assign double value to the float data type because double is bigger and float is smaller. Logically, if you think there is a small bucket and there is a big bucket, you can pour water from the small bucket into the big bucket. But you cannot pour water from the big bucket to the small bucket completely. Same applies to the data types. Coming back to the program, here we have defined 4 variables, n1, n2, n3 and avg. And the data type declared is float. So as soon as the interpreter reads this line, what happens inside the memory? Memory for variable n1 is reserved. We have assigned value 21.4 to variable n1. So value 21.4 will be stored inside the memory reserved for variable n1. Comma is the part of syntax. If you want to declare or define many variables on the same line, you can use commas. The next variable defined is n2. As soon as the compiler will read n2 equal to 40, it will reserve memory for variable n2 and value 40 will be assigned to it. Now n2 is also a float variable and we are assigning value 40 to it. Value 40 doesn't have a decimal point, hence it is treated as an integer value. Here, the interpreter internally converts this integer value into the float value implicitly, that is automatically, because it is not a lossy conversion. Hence, value 40.0 is stored in variable n2. Same happens with variable n3. Memory for variable n3 is reserved and value 51 is stored. Internally it is converted to the float value and value 51.0 is stored inside variable n3. Next is variable average, that is AVG. Memory for variable AVG is reserved, yet any value is not assigned to it. Next statement is the calculation. AVG equal to n1 plus n2 plus n3 inside the parenthesis divided by 3. This is the formula for calculating the average. So, AVG equal to value of variable n1 will be invoked, that is value 21.4 plus value of variable n2 will be invoked, that is value 40.0 plus value of variable n3 will be invoked, that is value 51.0. The order of operation is same as we do in mathematics. Brackets are solved first. So the addition of n1 plus n2 plus n3 is done and it is divided by 3. The answer you get is 37.466667 and it is stored in the memory space reserved for variable average over here. You need to print the output. To print the output to the console, in Java we invoke system.out.println method. Inside the parenthesis, text is written in double quotation marks and variable AVG will invoke the value stored in it, that is value 37.466667, and it will be printed on the output screen. So your output looks like this.